Hey everyone, welcome to the last video of this series. So you may be wondering why the series is so short. From what I've seen, at least with the year 7 syllabus and things I've worked through with students I tutor, the at this stage the concept of probability and the topic is quite brief. So I've given you guys a lot of kind of hopefully a lot of conceptual knowledge to put you in a good position for at least understanding how probabilities work, as well as going through complementary probabilities. These are the two big key concepts. All I want to do now is run you through approaching a probability example question. So this is one I've picked out from the textbook of one of the students I tutor, and this is a pretty good question to for you to sort of practice laying out your probabilities and really honing in those skills and identifying the different events and how to lay out these types of fractions. So here we have a question which states the numbers 1 to 10 are written on 10 identical balls and placed in a bag. If one ball is drawn at random from the bag, find the probability that the number is all of these different possibilities, right? So let's draw this bag. And you obviously don't have to do this. This is a little bit time consuming, obviously, but I'm going to draw a bag with all of these numbers here. 4, 5, 6, 7, 8, 2 more, 9, and 10. Obviously, these balls aren't identical with how badly I've drawn them, but you get the idea. So before we do anything, how many possible events do we have occurring in terms of just looking at if a ball was drawn from the bag, how many possible events can occur? Well, we have 10 balls, so there are going to be 10 possible events. So that tells us most likely that every fraction we get, every probability we get, is going to be a fraction of something out of a possible 10 events because we have 10 identical balls in this bag. So once we've established that it's going to be sort of something over 10, everything else becomes a bit of a counting act, right? Because, well, we want to find first the probability that the number is a 6. Well, there's only one 6 here, so my probability would be 1 out of 10, 1/10. Sorry, I should be writing in notation of probability of a 6 equals 1 out of 10. But it's as simple as that, right? Once we've identified all of our possible events, at this stage of our probability journey, we're just pretty much looking at everything we could possibly get and just making up these fractions, calculating these probabilities. Now, what about part B? Well, the probability that the number is even, well, let's just count the even numbers. We have 2, 4, 6, 8, 10, which is 5 out of 10. So probability of even equals 5 out of 10. We could have also said, well, there are going to be odd and even numbers. The only number in here will be an odd or an even, every possible number we could get. And half of these numbers from 1 to 10 would be even, which also checks out because we can simplify this fraction of 5/10 to a half. All right, what about C? We are looking for the probability that the number is less than 8. Well, okay, so that we can do in a couple of ways. We can either, we'll just count that the amount of numbers that are less than 8. So we have 1 through to 7. So 1, 2, 3, 4, 5, 6, 7 possible. There were 7 possible events that could fall here. So the probability of less than 8 equals 7 out of 10. Fraction of 7/10. We could have also said, looked at this in terms of complementary probabilities like we did before. We could have said, well, we have 3 numbers that are 8 or more. So the probability that it's not 8 or more is the complementary event to that, is the probability of something being less than 8. So we can subtract 3/10 from 1 and get the exact same answer of 7/10 here. Okay, we'll go part D, probability that it is composite. So for a bit of revision, these composite numbers are composed of 2 smaller numbers. And this not including the number itself with 1. So the composite numbers we're looking for here, well, 4 is a composite number. We get this by multiplying 2 by 2. 6 is a composite number. 8 is a composite number. 9 and 10. So we got 1, 2, 3, 4, 5 out of 10. Which we can also simplify to a half. All right, couple more. We're going to look for the probability that one of these numbers is a factor of 12. Okay, well, which ones are these going to be? Well, we have 2, 3, 4, and 6. These are a factor of 12. Well, I guess you could say 1 is technically a factor of 12 because 12 multiplied by 1 is 12. So as a technicality, let's just include the 1 here as well. But you see what I mean? We're really just counting the different possibilities we can get and expressing those as fractions. So let's include the 1 as well. So we get 1, 2, 3, 4, and 6. So our probability factor of 12 is 5 on 10, or a half again. Almost there, guys. We're going to look at which ones are a multiple of 3. So here we've got the 2 key ones, 3 and 9. So I might stop here because you can see that once we've laid out all of the possible events we can have, so this being the denominator, we can essentially just count the rest of them. Now, this not a 7 as well. That's a complementary probability. You can actually have a go at this one to practice if you'd like to pause the video. But essentially, we can just count either every number that's not a 7, or we can count the 7, find its probability, which is 1/10, and everything that's not that would be 9/10 because of this complementary probability idea we looked at before. So just understanding how to lay out these probabilities, which you would have gotten in the first video of this series, and understanding complementary probabilities in our second video, those are 2 tools you can have in your mathematical toolkit to approach these types of questions. Now, probability does get harder in later years, but for the time being, we'll leave it here and you can just refer to those 2 videos because they give you a nice overall picture of this level of probability. Because the hardest part is just finding all the possible events, and then finding all of our other probabilities, which we're given in questions like this, and find what the fraction of that event happening is of the entire picture. So probabilities are portions of a whole. The whole being, as I've said before, every possible event occurring. Now, I'll leave you there. This won't be the last time we look at probability, but until then, I will see you soon, I guess. And that is the end of our series. Thank you for joining me. I'll see you next time.